Welcome to the Mixed Reality Ultrasound Guided IV Access Simulator. This robust, turnkey mixed reality simulator simulates upper extremity for practicing, learning, teaching, and debriefing an ultrasound guided IV access procedure. It is dry, requires no fluids, and can be set up in 7 minutes from a padded case that meets checked airline luggage weight and size limits. The ultrasound-guided IV access simulator was also designed for future addition of arterial access, peripheral nerve blocks, and Botox injections to the upper extremity with the anatomically correct muscles and nerves. The simulator contains a physical upper extremity anatomical block, simulated ultrasound probe, and tracked IV catheter placed over a tracked needle. The anatomic block includes the hand, forearm, elbow, and midway up the humerus. The forearm has a rotation element just below the elbow. Rotation allows for pronation and supination of the forearm and hand. The simulator can track the needle in 6 degrees of freedom with 0.4 mm accuracy via the needle tip. A blue or red LED lights up upon venous or arterial entry, respectively. The LED light remains on until the needle is removed from the vessel. The software was developed by the CSSALT team using the SMARTS SDK. SMARTS stands for System of Modular Mixed and Augmented Reality Tracking Simulators. The virtual 3D model depicts virtual vessels co-located to the physical model. When pressure is applied using an ultrasound probe, the veins collapse, but not the arteries. Trainees can observe arterial pulsation on the ultrasound screen. The virtual veins are placed with 3 different sizes and depths to train for short and long access approaches. The anatomical block is made to mate with the SMARTS platform. The simulation shares the same components with other SMARTS-compliant modular mixed reality simulators. In other words, the peripheral IV simulator can be a central venous access simulator in seconds, and vice versa. The anatomic visualization button toggles virtual skin visibility of the anatomical model. With the skin turned off, the vein and arteries of the forearm and hand become visible. The ultrasound button can be used to change the size of the ultrasound screen. The 3D visualization mode is useful for after-action reviews as well as introductory learning. The viewpoint of the virtual 3D model can be controlled with a preset of the virtual camera position, or by using Virtual Camera Controller, also called the Tangible User Interface. Hold the button on the virtual camera controller and move it around the physical model. The virtual camera viewpoint will follow the controller and move around the virtual 3D model. Release the button to freeze the virtual camera position. Once the needle is in the vein, press the Score Me button to get feedback on your performance. This includes adequate tourniquet application, proper needle entry and angle if a backwall occurred, and on proper catheter advancement. The participant's performance can be re-watched by hitting the Replay Procedure button. The virtual camera controller can be used to examine a replaying procedure from any new perspective.